All right. Well, by now, I hope that you guys are becoming more and more accustomed to doing these proofs, okay? And I know, I told you guys at the beginning, these proofs can be some of the more taxing, harder things that you'll cover in your math classes over the 4 years in high school. But again, I hope that you're kind of seeing that there's a pattern to them. I hope that you're seeing that they're kind of challenging in the fact that it's kind of like a mystery puzzle and you got to put the puzzle together right. And I hope that you're accepting the challenge and you're stepping up to the plate and you're kind of having fun with them, okay? Again, a lot of things in life come back to attitude, and sometimes some of the more difficult things, if you just keep working at it, you can see that you can become pretty successful. And so as we look at this worksheet here, we're going to be working on sections 4.1 to 4.6, the review of this. Continue to think through this process with me. Don't just absent-mindedly write down this information. If you do, you're not really learning the concepts, okay? If you can be a step ahead of me as we talk through this information, by the time you get to the test, you'll be so confident you're just going to knock it out, okay? And so looking at the problem, we're going to skip the very first one there on the worksheet. We're going to go to the second one right there in the middle on the front side. And we're going to work this one out together. Now, with these proofs, one of the things I haven't really encouraged you guys to do, but I'm going to start to do is kind of set up, because let's face it, we've got 5 ways to prove triangles congruent right now. You've got side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. And you need to kind of think through the process before you start laying out your information on your chart, okay? Because we want to know what direction we're headed, okay? And I'll be honest, if you get to the test or quiz and you have no idea what direction you're headed, then just start to put information down. It's possible, and I know you guys have done this before because you've problem solved. It's possible that you could eventually come up with the answer as you stumble upon it, just because you were putting stuff down. So let's take a look at this first proof here and see if we can figure out what direction we're headed, and then start to put it into our proof. Okay. So as I look up here, we have EH congruent to FG, so I'll mark those two congruent. Okay. And we also have perpendicular lines. Now we've been talking over the last couple of days that perpendicular lines lead to right angles, so I'll put those down right there. And I would hope that you guys are already seeing by now the reflexive property, okay? And so as we look at those two triangles, if you don't see it very well, you can always draw the triangles separate from each other. Maybe that would help some of you. And just analyze, what do we have, and which direction am I going to go to prove the triangle's congruent? Well, what we have right now is what we talked about yesterday, right? Hypotenuse leg, okay? And again, that's the one way that students always forget. And I guarantee I'm going to use it on the test, okay? And you'll look at it and you'll either claim no conclusion or you'll use that gosh darn angle side side, okay? But we know that that can't happen. All right, so as I mark out the given here, now we know what direction we're headed. Let's start to lay things out. Well, I think that most of us will put down the reflexive property first. Okay, so reflexive property. Okay, and I'll go ahead and say EG is congruent to EG. All right, very good. And now we can go ahead and mark it on our paper. All right. The danger of marking it on the paper before you put it into the proof is you might forget to put it in the proof. Okay. All right. Now, how do we get to hypotenuse leg? Well, we first have to prove right triangles. In order to have right triangles, you have to have a right angle. So what I'm going to do here is I'm going to say this: angle HGE and angle FEG are right angles. Okay. What led me to the fact that those have to be right angles? Well, it's from the given, the definition of perpendicular. Okay. So I can put that down. And as I said before, if I have right angles, I know I have right triangles. So step number 4, I'll say triangle HGE and triangle FEG are right triangles. Okay, why are they right triangles? Because they have a right angle in them. Well, what led me to that? Well, it's the definition of a right triangle, okay? Which says if you have one right angle, you have a right triangle. Okay. All right, now I have right triangles. I have a pair of hypotenuses congruent. I have a pair of legs congruent. So now I can go ahead and say that the triangles are congruent. Make sure I match that up right. HGE, FEG, yep. FEG by hypotenuse leg. Okay. But that's not what we're trying to prove congruent, is it? Okay, and so as we talked the other day, we want to say that angle H is congruent to angle F. So I'll go ahead and go on down here. Boop. That angle will have to be congruent to that angle by CP CTC. Okay. Now, again, there's multiple ways to sometimes prove things. And as I was just filling this out, I started to think of another way that you could attack this, which is the cool part about a proof. You don't have to go the same way. Variety, it's the spice of life. Here's what I was thinking, okay? Ignoring all of this right here. If I go ahead and prove, based off the fact that these are right angles, okay, from the fact that we have perpendicular lines, you could technically go ahead and, maybe I can't do that. I take that back. I was misspoken. I was going to use alternate interior angles. Yes, these lines would be parallel, but I could not prove this angle congruent to this angle because there's no transversal shared. So I was misspoken. You still needed to prove the triangle's congruent by hypotenuse leg. So again, the analytics of it all. Make sure you're analyzing things accurately. So, all right, let's go down to number 2. Looking at number 2. Down here. All right, I have a point that's missing in this problem here. I'd like you to go ahead and draw it out for me, and that is going to be this point right here, okay? Now I'm going to be honest with you over the next, the next 3 problems I'm going to work out with you guys. This is actually where we're headed tomorrow, okay? And what it is that we have some triangles that are overlapping each other, and we have to separate them and then analyze what we have. So here's what I want to do, and I'll try to highlight this. If we know that SA or AS is congruent to RT, I'm going to go ahead and do this right here using my highlighter tool. Okay, those two are congruent to each other. And we also know that, let's see here, AT is congruent to RS. All right, I'm going to go ahead and highlight this, AT and RS. And then we want to prove angle TSA congruent to angle STR. So if I highlight this, angle TSA would be this angle right here. Okay. And angle, which one was it? STR would be this one right here. All right. So the question then becomes, which pair of triangles do we want to prove congruent to each other? Well, I hope it's pretty obvious. I've tried to highlight everything from a perspective of green triangle versus yellow triangle. You know, those are the 2 triangles we want to prove congruent. So what I want you to get in the habit of doing as you look at those 2 triangles is going to be this. I want you to draw them separate of each other. Okay, and it doesn't have to be super accurate. I know that some of you really struggle with your shapes here, so Just something approximately close to what we can see on the picture there. Okay, and that's what we have. Now, I'm going to mark out the given here that RT is congruent to AS, and we know that AT is congruent to RS. Okay, and I can't really mark this segment here and this segment here out congruent within that picture. That'd be kind of hard to do, so I'll just leave it down here. So from there, what is shared between those two triangles? Okay, is there something that overlaps itself? Is there something that's the exact same in one triangle as the other triangle? And the answer to that would be yes. ST, that segment there, is the same in both triangles. So, and you can see that yellow right there with the green, it's the exact same segment. So for step number 2, that's where I would go. ST is congruent to ST, again by the reflexive property. Okay. All right, now from there, I'm going to mark my diagram here. Those are congruent. Oh, now what do we see? We have congruent triangles by side, side, side. So we have triangle STR is congruent to triangle, let's think here, STR, that'd be TSA. Okay, again, make sure, the one things I worry about as I write this out for you is you're not thinking through those corresponding vertices, okay? Make sure that you're matching up everything correctly in your mind and that makes sense to you. Because this right here is easy points, don't miss that, okay? All right, from there, can I then state the angle TSA, so angle TSA would be this angle here, would then be congruent to angle STR, that angle there. Well, these two correspond, don't they? So I can say that. So angle TSA will be congruent to angle STR, again by CP, CTC. Okay, so a very simple 4-step proof. The hard part about the proof is that we had to separate the two triangles from each other in order to see how to prove what we were looking for. Okay, so that's the new concept, and we'll be working on that tomorrow to separate those. All right, let's go to the back set of your worksheet now, and we're going to look at 2 more as part of your notes, and then I'm going to let you do 2 other proofs, the last 2 on your own, okay, or with a partner. It doesn't really matter to me, okay. So as we look at this next one, here's what we have. We know that AB is congruent to CD. I know that BC is congruent to AD, okay, and that BE and FD are perpendicular to AD, okay. Well, the question I want you to ask yourself is this: what triangles do we know the most information about? We've actually got 1, 2, 3, 4, 5. We've got 6 triangles up there. I think you can see the 4 real clearly. Well, if you look at ABC and ADC, you can see those 2 triangles as well. So you got 6 triangles up there. Which 2 triangles do we know the most about? I hope that you would see that if you look at triangle ABC and triangle CDA, we know the most information about those. We know 2 of their 3 sides are congruent to each other. Okay? So again, I'm going to get in the habit of drawing those 2 triangles separate of each other. Okay, so something like this. A, B, C, D, and I'll mark it out the exact same way I have in the picture up there. Okay? Now, this is one of those problems, if you get to it on a test or quiz, just start putting stuff down that you know to be true. And you'll start to see some things work out in your favor. So the next thing I'm going to do here is I'm probably going to put down the AC is congruent to AC. Again, by the reflexive property. Okay. All right, now if I go ahead and mark that in my diagram, surprise, triangles are congruent. Sweet. So if I go ahead and write that out, side, 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 triangle, let's see here, ABC is congruent to triangle CDA. Awesome. Okay, so that was pretty simple there. Now from that point, I then have to figure out what other pair of triangles would have both of these segments in them. Well, as you look at the figure, you could go ahead and say this triangle and this triangle have both those segments in them. And you could say that this triangle and this triangle have both segments in them. Okay? And so as I look at that, you know, you can choose either set. It really doesn't matter at this point. All right? But let's all choose the same pair of triangles so that we're working on the same proof. Okay? You work on the other two triangles, it's going to be the same reasons, but it will be different statements here. So here's what I'm going to do. I'm going to go ahead and draw out triangle BEC and I'm going to go ahead and draw out triangle DFA. So BEC, FD, Federal Drug Administration. All right, FDA. Okay. So what I have here, boom, boom, sweet. Okay. Doesn't look like a whole lot. How in the world am I going to prove these two triangles congruent? Well, here's what I'm probably going to do. Let's go back to the given. BE and FD are perpendicular to AC. What does that mean? There's got to be a reason why it's there. What does that mean? Well, hopefully you're thinking, I know that these are going to be right angles. Okay? So I'll go ahead and write down that angle BEC and angle DFA are right angles. Okay, how did I know that? Well, it's from my understanding of what perpendicular is. So definition of perpendicular. Okay. Now, I don't know how I'm going to prove the triangle's congruent quite yet. Is it going to be hypotenuse leg? Is it going to be angle, side, angle, side angle, side? Well, I don't know. But here's what I want you to think through with me. If I go ahead and highlight, let's see if this will work. Highlight everything. Okay. From triangle ABC. Okay. And then if I highlight triangle ABC over here, here's what I see. I see that this side BC is the same as that one there. Okay. Outside of that, there's only one other thing that's the exact same measure in this triangle as it is in this triangle over here. And what I hope you're seeing here as I go back to my pen tool here is this, that this angle right here is the same angle as that angle right there. Okay? And I hope that you see that this angle here is the exact same angle as that angle there. Okay? You can see it up here in the big picture that this angle here, which is the same one here as it is here, okay, is the same as this angle here, which is the same as here as it is here. Okay? So what I would write down is this. I know that I'm probably going to prove, I can put the right angles up here too if you want to. I'm going to prove these two triangles congruent by angle, angle, side. Angle, angle, side. So if I'm going to do that, I'm going to go ahead and state that angle BEC is congruent to angle DFA because all right angles are congruent. Okay, all right angles are congruent. And then I can go ahead and put the angle, let's say BCA, will be congruent to angle DAC. Okay, and again, we're talking about these two angles right here because these two triangles are congruent, or by CP/CTC. Okay, so number 6, CP/CTC. Corresponding parts of congruent triangles are congruent. Whew. And we're not done yet. Now, where do we go from there? Number 7 would be this. I now know that these two triangles are congruent by angle, angle, side. So I'll put that down. And then I want to match up their corresponding vertices. So it will be something like this. Triangle BEC is congruent to triangle DFA. Okay. Now, where does that lead me from there? Well, if those two triangles are congruent to each other, I then would know that this segment here would be congruent to this segment here. Okay, so BE is congruent to FD, or DF, either way, by CP/CTC. Okay. Now let's talk order. I realize that was a lot, and your minds might be blown by now. Okay, but stick with me here. I think that once you've got it written out, you're like, yeah, that makes sense. The problem is could I come up with that on my own? Well, the good news is we're going to practice quite a few of these before we get to the test. Okay, and the hardest proof on the test, I've actually made a fill in the blank with a key. Okay, so you've got an opportunity to succeed there, even if you're not real confident with what you're doing. Now, the hard part about that is this: fill in the blank with a key. If you start to put in the wrong part for the different, it's like a multiple choice test. It's like dominoes; they'll all fall down. Okay, and we don't want them to fall down. We want them to stay up. So, if I talk order here, folks, you would need to put steps 2 and 3 where they're at. Okay, they have to be there. You have to know that. There's no way around those two. Okay. Now, steps 4, 5, and 6, the order can be shifted. I could actually take step 6 and put it up here at number 4, or I could shift it down to number 5. The only order between 4, 5, and 6 that matters is that 4 at this step has to come before that step. Okay? And then from there, obviously, 7 and 8 have to be where they're at. Okay? Because the logical order has to be in that manner. Whew. One last proof. Let's go down to number 4, and let's make sure that we know how to do this one. All right. So looking at number 4, let's try to figure out which way we're going to prove the triangle's congruent before we go ahead and prove them. Actually, maybe it'd be a good idea just to understand which triangles to prove congruent first. So what I'm going to do, if I go ahead and put GJ congruent to HK, okay, maybe it'd be better to highlight that so we can see that. Okay, so if GJ is congruent to HK, all right, and we know that GH is perpendicular to HJ. So I'm going to put a right angle symbol in there. And we also know that, let's see here, JK is perpendicular to HJ. Okay? So what we see in this picture up here, maybe I should say this, or ask this question: which triangles do you think we want to prove congruent first? Okay? Which set of triangles? And I hope that your eyes are drawn to the fact that we have a green triangle here again, and then the yellow triangle. okay? And so if I go ahead and draw those two triangles separate of each other, here's what we have. G, H, J, K, J, H. Now the given told us that those two were congruent to each other already, so I'm going to put that down. From there we have perpendicular lines, so I'm going to jot down that I have a right angle here before we do anything else. Okay. What else can I mark congruent that isn't already congruent? Because I don't know if I'm using angle side or hypotenuse leg as of right now. Okay. Well, I hope that you see that HJ is the same in both those triangles. Okay. So what will we be using to prove triangles congruent? It's going to be hypotenuse leg. Okay. Why do I keep bringing up hypotenuse leg? Again, the reason is because a lot of people forget about this one. I don't want you to forget it. Okay. So number 2, I'm going to put down that HJ is congruent to HJ by the reflexive property. Okay. Number 3. Because, and the reason I put that one down first only is because I think you guys are going to see that first when you start to see how these triangles fit together. Okay. From there, we know we have perpendicular lines, so I can go ahead and state this, that angle GHJ and angle KJH are right angles. Okay, and again, that comes from our definition of perpendicular. Okay. All right. Now from there, if I'm going to use hypotenuse leg, don't forget to prove we have right triangles, because you can't have a hypotenuse unless you have a right triangle. So triangle GHJ and triangle KJH are right triangles. Okay. And then from there, I don't know why I just did that. Are right triangles. Sorry folks, I got a little distracted there. I took a peek up at the proof as I was writing that. Didn't even see where I was writing it. Okay. Why are they right triangles? Well, it's from our understanding of what a right triangle is. So definition of right triangles. Okay. And then from there, to finish things off, I then will know that triangle, let's say GHJ and triangle KJH are congruent by hypotenuse leg. Okay. And then the last one, number 6. We will know that, let's see here, well, GH and KJ are a part of the two triangles that we just proved congruent, so I know that they will have to be congruent. So GH will be congruent to KJ, again by CP/CTC. Okay? So, hopefully that made sense to you as we work through that. Again, I'm trying to hit down the hypotenuse leg theorem to make sure that we don't forget that one for the test later on. So here's what I want to do. In looking at the last 2 proofs from the worksheet here, these are what's due for tomorrow. That's your homework. I don't think the very first one is going to be too difficult for you, so I'm going to let you guys, without giving you too many hints there, go ahead and do that one for me. And the other one that I want you to work on is in the middle of the back page, and here's what I'm going to do. I'm going to tell you which 2 triangles you want to prove congruent first. Okay? You're going to first want to prove triangles, just to make sure you understand this, we're going to do it in baby steps. FLA will be congruent to triangle FKA. You want to prove those two congruent first, okay? Now from there, which other two pair of triangles do you want to prove congruent? Do you want it to be JLA and JKA, or do you want it to be FJL and FKJ? I said it wrong. FJL and FJK. It really doesn't matter. So let's do this so that we're all on the same page. For the second pair of triangles you want to prove congruent, you want to prove triangle JLA congruent to triangle JKA. Okay? And that will lead you to LJ being congruent to K and KJ. Okay? So I hope that made sense to everybody. If it didn't, talk to a neighbor. And I'll be back to help you out as well. So hope you have a great night. Good night.